And I want to thank Farming Smarter for inviting me and allowing me to participate in your meeting. Jamie asked, she gave me the title, The New Normal, and I'll explain it in just a minute. But first of all, I want to start my talk with a video, just a 12-second video. And I'll just give you the context. This was last summer in the Porcupine Hills, straight north of Pincher Creek. And I was up there with my wife and a couple graduate students, a couple students from the Czech Republic, and we were chatting with this cattle producer. And he said something that struck me as interesting, so I asked him if he would repeat what he said. I grabbed my iPhone and I pointed my iPhone at him and asked him to repeat what he said. You wouldn't mind saying that about the 60-year cycle again once more. What did you find in the trees?
Well, I found, looking at tree ring growth, that there's an approximate 60-year weather cycle in this country. But 60 years isn't definite. It could be 70 years, and it could be even less. With weather, there's nothing written in stone.
Okay, were you able to hear that? Good. Well, he told you everything you need to know about the weather. So if we can open the cash bar, I think I'll indulge at this point, because I was struck by what he said. Although, you know, scientists and farmers make the same observations about the weather, but scientists get paid to explain it, so I guess that's what I'll do for the next 25 minutes. And by the way, the reason I think that Jamie asked me, she gave me a heading or a title of The New Normal is that's the name of a book that I wrote a couple of years ago with some colleagues. The subtitle of the book is The Canadian Prairies in a Changing Climate, so that gives you a sense of what the book is about. So that observation that Reno made, that there's a 60-year cycle, he drew that conclusion after looking at a lot of stumps, because up in the Porcupine Hills, they cut down lots of Douglas fir. He's cut down lots of Douglas fir, run them through his sawmill, and in the trees, he saw this 60-year cycle. Well, I've also looked at a lot of trees, trying to explain the climate. This picture was taken 25 years ago. That little guy was 4 years old, and he kept saying, "Dad, cut this one. Dad, no, cut this one." This was a clear cut in the Cypress Hills, because back in the 1980s, they were clear cut logging to get rid of the pine beetle. So we stayed on the Grayburn Gap Ranch. Back when Dan Reeser was dabbling in tourism, we stayed with Dan for a few summers, and we collected a lot of wood in the Cypress Hills. These trees were living, well, they had just been cut down for logging purposes, but we also collected in the Cypress Hills a lot of dead wood. And a lot of that dead wood was in corrals and barns and sheds like this one, so I spent a couple summers just driving around the Cypress Hills, and every time I saw an old barn or a shed, I would ask the landowner if I could have some of the wood, and people were incredibly cooperative. This particular shed, I hauled a couple big logs out of the base of the shed, and I took some wood with a chainsaw, and some of the wood that was left, many years later, ended up in the Cypress Hills Winery. So Marty and Marie, who operate the Cypress Hills Winery over in Saskatchewan, have actually incorporated some of that old dead wood. This is behind the bar. This is over the mantle over the fireplace. And those logs contain a record of the climate of the Cypress Hills. Because, of course, trees are plants. They need heat, water, nutrients, and light. Well, in this part of the world, in the summertime, there's plenty of heat, there's plenty of nutrients in the Cypress Hills, there's lots of light. And so what determines how much a tree grows is water. And therefore, it's possible by using wood to determine how much water has been available for plant growth every year over the length of the life of the tree. Well, this happened to work pretty well. Back then, we had a bit of support actually from the local ad board. So from the egg producers gave us enough money to spend the summer in the Cypress Hills. But it turned out that it worked so well that I've never stopped. And now we have more than 8,000 pieces of wood. So this is our workshop at the University of Regina. This is Samantha. She's from a farm near Bethune, Saskatchewan. And so every summer, actually every winter, I hire students to polish the wood. There's our DeWalt planer, our DeWalt miter saw, our DeWalt palm sander, our DeWalt belt sanders. I think I should get a little cut from an endorsement deal from DeWalt. But we have more than 8,000 pieces of wood, and we've collected this wood at 170 locations, right across North Dakota, Montana, up through Alberta and Saskatchewan, across the NWT and over into the Yukon. And we've been paid to do this because we've been able to determine the climate of the last 1,000 years of this part of the world using wood. But you'll notice that there's a lot of dots in the Rocky Mountains, and that's where we've collected most of the wood. For a few reasons. One, that's where we find the oldest trees. We find trees that are 1,000 years old if you just go up west of here. But also, this is where virtually everybody gets their water. If you live in Alberta, if you live in Saskatchewan, most people get their water from snowmelt from the Rocky Mountains. So because we are concerned about drought, because we are concerned about water supplies, we go where the water comes from. So for example, this past summer, we were up in the Rocky Mountains near Banff, and this is that little guy that was 4 years old. He's now 29, and he doesn't say, "Dad, cut this one." He said, "Dad, let's go into Banff because there's beer and there's girls." So we collected a bunch of wood at Banff. We had to get rid of a grizzly bear. This grizzly was in the way, and so before we could collect wood, we had to wait till the grizzly got out of the way. And we took this wood, and for the city of Calgary, who's paying us right now, the city of Calgary, we've given them how much water's been in the Bow River every year back to the year 1107. Now, the way this information is presented, if it was a wet year, it's blue. If it's a dry year, it's red. So you can think of red as being drought. And I want to point out a few things. First of all, if you look off to the right edge of the graph, that's the last few decades. And you can see that there are some long red bars because 1984, 1988, 2001 were dry. They were really dry. I mean, 1984 is about as dry as it gets because you can go back 1,000 years and there's just a few other years that are drier than 1984. But what we have not seen is we have not seen decades in which there was no water. So I want to take you back, and if you start from the right, which is the year 2007, and you go back to the 1840s, 1850s, 1860s, if you can find them on this graph, there's a period of 30 years in which a few years, maybe half a dozen years, had a little bit of water, and every other year was dry. 1850s, 1860s, a period of about 25 or 30 years in which there wasn't much water. Now, I also want you to squint, and I want you to scan this graph, and I want you to notice how the blue and the red tend to occur in chunks. Chunks of about 30 years. There's about 30 years when, not every year, but most years are wet, and then chunks were about 30 years when every year is dry. 30 plus 30 is 60. That's the 60-year cycle that cattle producer was talking about. So let's go, first of all, to that period of the 1850s, 60s, and 70s. It wasn't that long ago. It was just before the settlers came. What was going on? Well, the government in the UK sent a guy named Captain John Palliser out here because they wanted to know, should we send settlers to the Canadian Plains? And what did he say? He said, no. He said, don't bother. He said an area of about 80,000 square miles, where we are right now, will forever be comparatively useless. And he wrote this in 1860, which was in the middle of a 30-year drought. But of course, the government ignored the scientists. Nothing has really changed up to, really. And the railroad encouraged people to come. The developers encouraged people to come. And they came, and they built the railroad, and they built Medicine Hat. And in the very first edition of the Medicine Hat newspaper, there was an editorial, and it said it would be almost criminal to bring settlers here to try to make a living out of farming. This was in 1891 Medicine Hat Times, because it was the end of a 30-year drought, and it was the beginning of 30 relatively good years, the 1890s, the 1900s, and the 1910s. And so the population of Alberta and Saskatchewan increased by more than 400% in a single decade. They came. My grandfather came, so I know this homestead because it's my grandparents' homestead, north and west of here. And then, of course, there was 30 relatively dry years. And if you take a piece of wood, here's a piece of limber pine from the Old Man River Basin. This is near the Waldron, in the Waldron Ranch, north of Lundbreck, Saskatchewan. Sorry, Alberta. I actually have a place there. I have 52 acres and a house there. But I also live in Saskatchewan. So this piece of wood has 812 annual rings. And if we zoom in and you scan this, you can see that there's about 20 or 30 years in which the rings are wide, and then a group of narrow rings and a group of wide rings. And for 812 years, there is that 60-year cycle that the cattle producer saw. But of course, we're scientists, so we have to do things in a bit more technical way. We take 8,000 pieces of wood, we scan them on a scanner, we put them in a computer program, and that computer program picks out the length of the cycle. So across the bottom, you have the last 800 years in the Old Man River Basin, OR, and along the vertical axis, you have the length of the cycle. And if the cycle is powerful, it's in red. I want you to notice that at around 60 years, there are these red blotches that show up going back 800 years. That's the 60-year cycle. And if you cut it in half, it's about 30 years, and at about 30 years, there are some red blotches. But there's some more red blotches. Between about 4 and 8 years, there's some more red blotches. So the scientific conclusion is that the climate of this region and the water supply and the soil moisture has these strong cycles. One cycle is at about 60 years, and another cycle is about 4 to 8 years. Now the explanation. That short cycle of 4 to 8 years, it's driven by El Nino and La Nina. And this map shows a map of the world. Maybe you can find North America off on the right-hand side. But I want to draw your attention to the middle of the Pacific Ocean basin. Along the equator, it says that it is warm and wet. That's El Nino. If it's cold, it's called La Nina. And what we're showing here is when it's warm, when there's an El Nino, it is warm and dry in Western Canada. I'm not showing you the opposite. The opposite is when it is cold along the equator, it tends to be wet in Western Canada. Now, you've probably seen those seasonal weather forecasts where they say that, next spring is going to be cold and dry, or it's going to be warm and wet. Those seasonal weather forecasts are based primarily on the status of El Nino and La Nina. That is the temperature of the Pacific Ocean along the equator. And it's really this phenomenon that drives the wet-dry cycle in the range of 4 to 8 years. But what about that 60-year cycle? That's called the Pacific Decadal Oscillation, because scientists have discovered that the Pacific Ocean basin flips between a warm phase when the water is relatively warm and a cold phase when the Pacific Ocean, the northern Pacific, is relatively cold, and this has a profound impact on the weather of the world, but especially Western North America. As you can imagine, if the ocean water is warm, then the overlying air is warm, and the overlying air is also moist, but that also affects the pressure of the air and the direction of the wind, so the entire circulation of the atmosphere is strongly affected by this pool of either warm or cold water in the Pacific Ocean. And at the University of Washington, they have plotted the Pacific Decadal Oscillation, which is basically the temperature of the Pacific Ocean, back to the year 1900. And what I've done is I've taken this PDO index, and if it is positive, I've shown it as being red, which is dry. And if it's negative, if it's below zero, I've shown it as being blue. And that's because in Western Canada, if the PDO is positive, our weather tends to be dry. When was the PDO positive? Well, it shifted in about 1920. From the mid-20s to the mid-40s, the PDO was mostly positive. What do you know about the 1920s and 30s? It was dry. The PDO shifted in the 40s. From the 40s to the mid-70s, the PDO was mostly negative. What do you know about the 50s, 60s, and 70s on the prairies? It was relatively wet, with the exception of 1961. It shifted again in 77, the 80s, and the early part of this century, or this decade, we had drought. There was a positive PDO. The PDO just shifted a couple years ago. What happened? We've had a series of wet years. This cycle keeps showing up, and I'll give you a few examples. This is south of the Cypress Hills. There's a cairn. It marks something called the Orleans Duck Factory, because in the 1940s, the New Orleans chapter of DU came up, and they built a canal, and they diverted water out of a creek into sloughs because they created a duck factory south of the Cypress Hills. And they had perfect timing because the PDO switched. It flipped in the 1940s. And this duck factory existed for about 30 years. They abandoned the duck factory in the mid-70s just in time because the 80s came along. So the entire life of this duck factory corresponded to a single phase, a wet phase of the PDO. They didn't know that, but that's how it turned out. Sloughs, lakes, we've just gone through a phase when most of the lakes on the prairies have been falling. I took this picture in 2008. I'd just given a talk in Sherwood Park. It was a nice day in September, and I thought, you know, I'm going to wander over to Cooking Lake, because when I was a kid, my dad, my brother, and I used to hunt in Cooking Lake. We had a duck blind. I'm going to find the duck blind. Well, I couldn't find our duck blind because I couldn't find Cooking Lake. It was virtually gone. But then the PDO shifted in 2008, and Cooking Lake is coming back. Now, those poor people in the background, they built these cottages in the 1970s when Cooking Lake was back there. And just after they built their cottages, Cooking Lake began to recede, and it receded kilometers out. And it's coming back. The lakes are coming back, and people don't like it. For example, at Sylvan Lake, their beach has disappeared. And they're rewriting the highway. The mayor points out that lakes across central Alberta have high water levels. Well, yeah, because the PDO flipped and we're coming back into a wet phase. They want to build a big sandbox. They want to spend $18,000 in restoring the beach. Well, don't do that. Just wait 25 years. If you wait 25 years, the PDO will flip again, and your beach will come back, and it'll get bigger and bigger and bigger. So the big part of the problem is we don't recognize these cycles, and we don't live with these cycles. If we did, we would save a heck of a lot of money. But it's not quite that simple, of course. Here's the level of the South Saskatchewan River at Medicine Hat. Lots of variability from year to year. That's El Nino La Nina. Here's the 60-year cycle. It shows up great in the South Saskatchewan River. But there's something else going on, and that is this gradual decline in not only the South Saskatchewan River, but all the lakes and rivers in Western Canada. And the only explanation for that is our climate is getting warmer, and our snow is gradually disappearing. This is from the US government. They just observed that October, this past October, was the 36th consecutive October that's above average. And it was the 332nd consecutive month. The last month that was colder than average was February 1985. Our climate's warming. And it's primarily good news. Here's some work done by Environment Canada scientists. They can't talk about it. They're not allowed to talk about the work, so I will. Showing that degree days are increasing, corn crop heat units are increasing. They concluded that the growing season is getting longer, the frost-free season is getting longer, there's more water available. Most of the impact of the warming climate is good if you live in Western Canada, and especially if you farm. Here's indisputable data showing the warming of the climate. But, and I got a few slides left, and here's the kicker, and it's why I'm here, is actually as the density of the atmosphere increases, as we increase the concentration of carbon dioxide and other gases in the atmosphere, satellite measurements show quite clearly that there is an imbalance between the energy coming from the sun and the energy that we're losing because we're trapping energy next to the Earth. And heat is building up somewhere on Earth. Now, some of that buildup of heat we measure using thermometers, but scientists, American scientists, have just concluded that a lot of the heat is being buried in the ocean. Most of the Earth is ocean. Water has a tremendous capacity to store heat. When you make coffee every day, you show that to yourself. And so a lot of the heat that we're trapping next to the Earth is being stored by the oceans. And they concluded this must have consequences. Sure, it has consequences. Where does our weather come from? Where does our water come from? It comes from the oceans, and the oceans are heating up. So, those cycles, those short cycles, those long cycles, they used to be natural, they used to be normal, but they're not anymore. So, the best way to explain it that I found was given to me by a producer from Vegreville. I gave a talk in Vegreville, and afterwards this producer came up and she said, you know, I think of the weather and climate as being a marble in a bowl. And I thought, wow, that's amazing. So a couple weeks later, I was asked to give a talk in the House of Commons to MPs, and I used that analogy, and it didn't work. But I think it's brilliant. The marble is the weather, the climate is the bowl. The marble rolls back and forth because on any day we can be wet or dry or hot or cold, so the marble's all over the place. But the bowl doesn't change because the climate is the average weather. But she said what we're doing is, with climate change, we're tipping the bowl. In other words, if you change the climate, you'll get weather that you don't expect. And so that's a tremendous way of explaining what scientists are busy doing. And I want to thank Jamie for asking me to come here, because if I wasn't here today, I would be in San Francisco of a meeting of 21,000 climate scientists. I sent my associate, I'd rather come to Medicine Hat. And those 21 climate scientists right now are meeting, and the one thing they do not discuss is climate change, because they all know it's a fact. And so by changing the climate, we're changing the weather, and the weather that we're producing is more extreme weather. We're producing conditions that are wetter than we've ever seen, and we're producing conditions that are drier than we've ever seen. So what we advise producers, if we're asked, is go out there and take advantage of all this extra heat. It's getting warmer, the growing season's getting longer, the winter's getting warmer, but you can do that, you can take advantage of the extra heat if you have a management system and technology that can cope with more water and less water at the same time. That's it, thanks.